to the internet. And so now we're assuming, yes, we do. We do have routes to the internet. And yet still, my employees are complaining they cannot get to the internet. So now the next step is, okay, can my router get there? Maybe my employees can't get there, but my router can, and that would help sort of guide me down the path of troubleshooting that I need to go. So that's the next step. From the actual command line of the router, I'm going to try to ping the internet. Now in this particular case, if this is a real world environment, you could ping anything in the internet. I'm saying, can you ping 8.8.8.8? From previous videos, we saw that that was the public IP address of Google's public DNS server. And if you really do have internet access, you should be able to ping that from anything. So this is a good thing that should always be up, that should always be pingable. Of course, that could potentially go down. So if you try to ping that and it doesn't work, I'd say try to ping something else before you assume that the entire internet is down. But so we're going to say that. Now let's say you try to ping that IP address or any other internet destination that you're aware of, and from your router. We're not doing this from the laptop, we're doing this on the router now, and the answer is no, I can't ping it. Just like the employee can't reach it, I can't reach it either from the default gateway itself. Okay, so here's how we would do that. We'd use the ping command, the exact same command that the employee would be using in their DOS prompt on their laptop. Now if we can't get there, one thing we could try doing from the router is doing a traceroute command. And a traceroute command, let's assume that this IP address we're trying to get to is hundreds or maybe even thousands of miles away from us, from our actual default gateway. So the assumption is when my router forwards a packet to this destination, it's probably going through many other routers before it finally gets to that destination. And what we're trying to discern here with the traceroute command is how far is it getting before it stops? Is it getting 4 or 5 routers deeper into the internet and then it's dying? Is it getting almost all the way, or is it just dying at the very next hop router upstream? Is it dying at my ISP? So traceroute could indicate that. Now actually you can do this command also in Windows. Now if you do this in the Cisco iOS command line, it's exactly like you see here. Traceroute, no space, altogether. You can also do a traceroute from your laptop. It's very similar. Instead of the word route, it's just RT. So trace RT and then the IP address. For example, here's what it looks like. I'll actually traceroute to that Google server. I have no idea how far away it is. I'm actually in North Carolina right now, so let's see how many routers I have to get to reach it. Okay, so my first, and the way traceroute works is if you're familiar with the structure of IP packets, you know that in every IP packet there's a field in the packet called the time to live field. And the way that time to live works is that when the packet is first generated from your laptop or tablet or whatever, it puts some initial number in that time to live field that's a non-zero number. Usually it's a pretty high number like 64 or 255 or something like that. Now as that packet reaches a router, before the router actually routes it, before the router forwards it, it decrements the time to live by 1 and then forwards it out. So if my initial time to live from my laptop to Google's network was, let's say, 64, when it got to my default gateway, normally he would take that number down to 63 and forward it. And the next router would decrement down to 62 and forward it. And the idea is, if some router out there gets this packet, let's say the packet goes through 63 routers, way far away, and then on that router way out there, he gets the packet in, it comes in with a TTL of 1. So start out 64, 63, 62, 61, then eventually goes all the way down to 1. Well, what does that router do? So when a router receives an inbound IP packet and it comes in with a TTL of 1, the router says, okay, I'm going to decrement the TTL to 0, because when a router decrements a packet with a TTL to 0, he says, I'm going to kill that packet. TTL of 0 means the packet can go no further. The buck stops here. So in normal stuff, when you're doing web browsing or your instant messaging or something, your initial packets are having some TTL value, some big number, and usually it's big enough to get the packet wherever it needs to go before it counts down all the way to 0. Well, how does that have to do with traceroute here? The traceroute command, what it does, it says, okay, I'm going to create a packet to whatever destination you want me to go to, but I'm going to start with an intentional TTL of 1. And what that does is the packet goes to the default gateway, he decrements it to 0, and then the default response of that router is he sends a packet back saying, I'm sorry, I had to kill your packet, the time to live expired. Here's the packet I had to kill. And that's what this first entry is here, this line number 1. That was the very first packet I had with a TTL of 1. My default gateway killed it of 10711. He decremented the TTL to 0 and responded back to me. Then I created another packet going to 8888, but this time with a TTL of 2. It went through my default gateway. He decremented it to 1. He forwarded it to the next router, which in this case was some router owned by Time Warner Telecom with this IP address, 66.194.117.41. He then decremented it to 0, killed the packet, sent a response back. So this trace route is actually a method of, by sort of creatively using the time to live field in the IP header, of sending a packet a little bit further, a little bit further, a little bit further, and seeing how far out you can get it before either it ultimately reaches its destination or it gets dropped somewhere. So you can see in my particular case, let's see here, to get to the 888 network, I went to 1, 2, 3, 4. I went to, eventually went to 10 routers. Actually, it went to 9 routers and then went to the destination. So Google's public DNS server that I'm reaching is 9 routers away from me. Now, so that's one thing. You could try troubleshooting. So for example, in my example, I say, okay, the employee says he can get to r2.com, but when he tries to go to the website of r4.com, I don't know if you can really see it or not, but up here in the upper left-hand corner is just spinning. The sort of that irritating spinning symbol which says, I'm thinking, I'm thinking, I'm thinking. It never really goes anywhere. So r4.com is not reachable. So let's do a trace route. Now the first step would be, what is the actual IP address that's being resolved by r4.com? And in the previous video, if you watched that, you saw that I had statically set a DNS entry in my hosts file so that R4 would resolve to 4.4.4.4. So my laptop already knows that. So let's do a trace route. Trace route 4.4.4.4. Now the very fact that I see something here tells me that my first packet at least made it to the default gateway. So I at least have connectivity to my default gateway, and I should see that here in just a second, that 1111, which is my default gateway. Okay, so my default gateway responded. And then I got to another router, which is 2222. Then I got to another router, which is 3333, and now it's timing out. And I'm not going to keep watching this, but I could watch this for another 5 minutes or so, and at this point, it's just going to keep saying request timed out over and over and over again. I think it goes up to, it goes up to 30 hops, and we don't want to watch it for that long. So what does this tell me as the employee? As the employee, it tells me, okay, this packet got to the 3rd router, but it couldn't get beyond the 3rd router. When it tried to get to whatever routers after that, something happened. We don't know what happened, but something happened. Now, as the employee, you would probably just call your network troubleshooting department and say, hey, I did a trace route and this is what I'm seeing. So now what would I do as a network admin? I could do the same thing. Let's go to my router and do a trace route from here. Trace route. Let's see, the employee says he can't get to 4444. Let's see, how far can I get? Oh, okay. Well, I'm reaching the next router up the line, which is 2222. I'm getting to the router behind that, which is 3333, but at that point, can't get any farther. Now, as the network admin, the next question you'd have to ask yourself is, okay, this router right here, 3333, does my company own that router, or does some other company own that router? If my company owned that router, my next job would be to get onto this guy. I would have to find wherever this router is with the IP address of 3333, jump onto him, and find out why he cannot reach 4444. Is there something going on with that router? If 3333 was not owned by me, but owned by my ISP, at this point it'd be my job to call up Comcast or Time Warner Cable or something and say, hey, I verified that I can't reach this website. It's not my fault. A traceroute proves that. It's beyond my network. Can you look into it for me? So that's one thing, troubleshooting. How far can I get with a traceroute? And that'll help me to identify, is the problem in my network or is it beyond my network? Once again, we could take a look at the show run output of our router, of our default gateway, and a couple of basic things we could look for. Are there some access lists? You know, maybe somebody hacked into my router and they implemented some sort of an access list that's causing this problem. Well, let's do that. So we know in this particular case we can't reach 4444. So let's just issue a show run and see if there's any reason why that might be the case. Okay, so back to my topology diagram. I know that to reach 4444, the router is going to be forwarding stuff out this way, and responses are going to be coming back this way. We know the router himself cannot reach it. So that would tell me I need to focus in on this interface right here. If there's some sort of an access list on here, that might explain why these packets are not making it to the destination or not coming back. And sure enough, when I look at this serial interface, oh, the access group command is here in the inbound direction. Now the access group command references an access list. So access group 1 says, okay, when a packet comes inbound, in other words, when a packet comes this direction in to my interface, I'm going to stop it and inspect it against the access list with the number 1. And that access list will tell me what to do. Well, access list 1 says if a packet with a source IP address beginning with 444, that's what this mask says. That says if the first 3 numbers are 444 and the last octet, the last number is I don't care. So if a source address is 444, deny that packet. If it does not match this, permit everything else. And that's why I'm unable to get to that website. It's not because my packets are not getting to the website. It's because when the website it tries to reply to me, his replies are being dropped in the inbound direction. Somebody hacked into this router and they installed this inbound access list, and this is what's killing my internet connectivity. So first step is rectify the problem. Get rid of that access list. It's not supposed to be there. I should say that access group. Okay, now, can I ping the website? Yes, I can. Go back to the employee. Hey, can you bring up the website now? Employee says, okay, let me take a look. r4.com. Yay, it came up. It's working. All is solved. So now your job is not yet done, right? Now you have to put on your investigator's hat and figure out who hacked into my router and what can I do to prevent that from happening again in the future. That's a video for another day. If there had not been an access list, let's say that had not been the issue, another more advanced thing you could look for is something called policy-based routing. Now once again, this would be an issue of somebody hacking into your router and putting a configuration in there that was not supposed to be there. But basically what policy, as a real high overview of policy-based routing, I'm not going to get into the details of that. Policy-based routing is something like this. Let's say you have a router and it's got several interfaces. And if you did normal routing, let's say that there was some destination out here, destination X, some web server. And normally if a packet came in this interface and we just did regular routing, we would route it out this interface. Let's just give some interface numbers here. Let's say this is 1, 2, and 3. Well, policy-based routing is a way that you can tell the router, hey, when a packet comes in, don't look it up in the normal routing table. I'm going to tell you explicitly where I want you to forward that packet. So I could implement policy-based routing right here on this inbound interface. PBR implemented. In which that when a packet came in that matched this criteria, whereas the normal routing table would forward it this way, if I was trying to be malicious, I could say, no, my policy-based routing is going to send it out this way. It'll never reach its destination because destination X does not live here. But that was my intent. If I was a malicious hacker, I'd say, okay, let me try to put some PBR in this interface which will redirect traffic out the wrong interface and kill network connectivity. And let's see if the network admin is smart enough to detect that in his config. So that'd be the other thing you'd want to look for. Look for some sort of interface level configuration that relates to policy-based routing that might be causing your traffic to be redirected out the incorrect interface. If you don't see that, okay, so once again, I can't ping the internet from my default gateway. I don't see any access lists that are causing the problem. I don't see policy-based routing causing the problem. I've already verified I have an actual route to the internet. It's not a routing problem. Well, at this point, you may want to just go to the upstream device. Now, I'm sure if we thought about it long enough, we might be able to come up with some other reasons why on the default gateway itself there could be some configuration there which could be causing the problem. But from a basic network troubleshooting standpoint, if you have a route to the internet but you can't ping your destination, then either the problem is when packets are coming back to you, you are able to ping it, but when the replies are coming back, you're killing those packets, and that would be an access list problem. Or when you're trying to ping it, you're going the wrong way, and that could be a policy-based routing problem. I suppose we could also artificially influence our routing protocol, so the routing protocol thinks it has a route, but in reality that route is wrong. That could be another thing. Just because you have a route in your routing table that says this is the route you use to get to the internet, check that route. Maybe it's not pointing the right way, right? If I go back to my diagram here for a second, in this particular case, chances are your default gateway probably has more than 2 interfaces. In this case, I've just drawn 2, but you probably have other ones. Let's just draw one other one here. Let's say this is fast Ethernet 0/1. So maybe I go into my router and the very first thing I say is, okay, do I have a route to the internet? Let's see, I know I should be seeing a route that says 0.0.0.0. I do show IP route and boop, there it is, 0.0.0. Okay, move on. Well, hold on a second. You may have a route, a default route, but is it pointing to the correct next hop? Maybe if I just take a couple more seconds to look at that default route, it might say, wait a second, I have an EIGRP route, and the next hop is 5556. Say, that's wrong. The next hop should not be out this interface here. It should be out the serial interface. This is wrong. So now the next question I'd have to ask myself is there something in the default gateway? Is there some hacked configuration that caused this to appear? That could be another thing I'd be looking for. Just because you have the route doesn't necessarily mean it's the correct route.